All right, so now we looked at the paragraph. Let's go ahead and look at a couple of examples. All right, the first example we're going to look at is the function y equals the square root of 3 minus x. All right, so we always want to revert back to what we've already done because it all builds upon itself. And so when we were talking about the quadratic functions, the first thing we need to find was the vertex. Well, this time we need to find which x's are going to work in this, okay? And we know that we can't have any negative numbers, so that means x has to be greater than 0. So when I say x, I mean whatever is inside of our square root function there. So whatever's inside of the square root has to be greater than 0 because we don't want any negative numbers out. So that means I can take this and set up an inequality that I can solve. So I'm going to take what's inside and I'm going to set up an inequality to figure out which x's are going to work. Well, that just looks like 3 minus x, so I just take what's on the inside and then I know that it has to be greater than 0. So the inside of my square root has to be greater than 0. And so once I do that, all I do is solve for x here. So I subtract 3 from both sides. This acts as my equal sign, so it's the same as solving equations. So I subtract 3 from both sides. I get negative x is greater than negative 3. Now I can't have that negative in front of my x, so I got to divide by negative 1. Divide by negative 1. All right. When I do that, I have to switch my sign. It's one of the properties of inequalities that we learned a long time ago. So I'm going to switch my sign. So I'm going to just turn it around. So instead of facing this way, I'm going to face it the other way. And then so I get x is less than 3. So all my x values that I'm going to pick when I do my table to graph have to be less than 3. And we can say less than or equal to because it can be equal to 3 also. All right, so now to graph this, I just make a table. That's our first thing we need to do whenever we're trying to graph. We need to try to make a table. And so we're going to make a table, XY table. You got X, you got Y, and we're going to pick some X and Y, X values, and then plug them in to get a Y out. And then, so I know it has to be less than 3. And if I pick 3, I know I'm going to get 0. So I'm going to pick 3. Um, If I plug in 2, I'll get 1. So I'm going to go ahead and pick 1. I mean 2. If I plug in 1, I'll get 2. I don't want that one. If I pick 0, I'm going to get 3. Don't want that. If I pick negative 1, remember this is going to be 3 minus negative 1. So we'll look in there. We'll get 4. So I'm going to pick negative 1. So I'll just pick these 3 points and then we'll go from there. So that means I got to take this 3 and I got to plug it in to figure out what y is. So y is going to be equal to the square root of 3 minus 3. Well, 3 minus 3 is 0. The square root of 0 just turns out to be 0. So I know this one is 0. Now I do the same thing for 2. I get y is equal to the square root of 3 minus 2. Okay, these are the numbers I'm plugging in. I'm plugging in 3 for the first one. Now I'm going to plug in 2 for the second one. And then so I get y is equal to the square root of 1. Well, the square root of 1 is just 1. So I know this is 1. And then now I do the same thing for negative 1. And I get y is equal to square root of 3 minus negative 1. Okay, notice I got minus negative 1. This turns that into plus. So it's really just square root of 4, which I know y has to be equal to 2. Now I can go ahead and graph it. I'm going to go ahead and use the graph it on the same graph as we did our original one because we want to see what changed and how it changed. All right, so we're going to go ahead and graph my first point over 3 up 0. So I'm starting here. And then I go 2, 1. So 2 up 1. And I go negative 1, then 2. So notice my graph is going the other way now. All right. So notice I end up with that graph there in green. And so that's the first part of the benchmark force. Now we do need to start talking about domain and range. And then so we'll do that now. So if we look at this one, all right, so now we've talked about graphing it. Now we're going to analyze the graph and figure out what all this information is. Just like we did before, we need to find domain, range, increasing interval, decreasing interval, x-intercept, y-intercept, and how is it different from the parent graph. And so that's what we're going to look at now. Domain is the x values that can go into our graph. Notice that my x's go from left to right. So we have a stopping point of our x's right here for our graph that's in green here. Notice, well, that one can be included. So we know we need a square bracket. All right, we're going to need a square bracket somewhere. The only limitation that we have on this graph is this point right here, is the x value in this point. And my x value here is 3. But notice it's farther to the right than the rest. It's the farthest to the right to the rest of my graph. So I know it needs to come to farthest to the right when I write my interval as a point. And then notice that, are there any restrictions back here? No, there's not. And that goes to negative infinity. And remember, that one needs to be a curved bracket. There's no restrictions here. It goes on for forever. Forever is infinity. Remember back to your days as a child. All right, and then we look at our range. In this case, what is the bottom that I can go on this graph? Well, the bottom that I can go on this graph is 0. I'm not going to go anywhere below 0, am I? So I know since that's the bottom, it needs to go on the left side of my interval, but it can be included, so we're going to put 0 here. All right, and this is for the example we did of y equals 3 minus, this is y equals the square root of 3 minus x. So that's the function we're talking about still. All right, so I know the bottom, the lowest is going to be 0, and it can be included, so I put that bracket there. And then, are there any restrictions on my y's? Do I have anything that's telling me I can't go up to 1,000,000? No, so therefore, we get that part. Now we need to figure out if it's increasing or decreasing. Notice this one isn't double-sided like when we did absolute value and when we did absolute value and when we did quadratics. So we look at this one and we notice it's only can be either increasing or decreasing. So we can't fill out both of those blanks there. So we got to pick which one. Now, just like when you read a book, we're going to read left to right. Okay, so as we follow this graph, we just trace it from left to right. Are my numbers, are my y values getting smaller or bigger? Well, notice this one's 2, then it goes to 1, then it goes to 0. So therefore, we're getting smaller, which means we're decreasing. Okay, so we don't have a increasing interval. We only have a decreasing interval. All right. So our decreasing interval here, notice it's going to start at x equals negative infinity, because we're going from left to right, so we're talking about our x's. Well, my x's are negative infinity, so I know I gotta start from negative infinity because it's gonna be decreasing the whole time. And where does it stop decreasing at? Well, it just stops decreasing at my point here, which is just 3. Notice in this one, our domain and my decreasing interval is pretty much the same there. Now we need to talk about x and y intercepts. Well, the x-intercept is pretty easy because x's intercept is where y equals 0. And if we take a look back at our table, we had y equals 0 at the point 3. So that point 3 is my x-intercept. So I automatically know my x-intercept is at the point 3, 0. You could just say 3, but it's more correct to write the point there. Okay, y-intercept is where x equals 0. And so that's something that we're going to have to find. Okay. Um, and it's really, really easy because all we got to do is take 0 and substitute it back into our equation, which is no big deal. So you get y is equal to the square root of 3 minus 0. Well, therefore, y is equal to the square root of 3. And then, so therefore, we can either leave that as it or we can make it a decimal. Um, I like being exact, so I'm going to make it the point 0 square root of 3. That's how you find the y-intercept. Now, how does it differ from the parent graph? So if we look, okay, we we can say how is it different? Well, the parent graph started at 0, but this one started at 3, so we moved it to the right 3. And what tells us that is this number inside of here. Okay, we added 3. Well, that means we went to the right 3 in that case. Then really didn't stretch it or shrink it or anything, but we did flip it across the x-axis. All right, so we flipped it um, horizontally, I guess is what you can call it, or with that. Across the y-axis, I'm sorry. All right, and it's not technically the y-axis, but if you told me that, I would accept that because we took it from it going this way. Now we just flipped it and made it go the other way.